Alright, I just wanted to do a Istio demo to kind of show some of the platform features if you use the service mesh Istio and what kind of it provides to each one of the projects on the system. So what I have is a proof of concept project that has a couple different components. Each one of those services are basically just being dealt with as kind of a standalone development effort. I apologize for the repo since I'm using submodules. It's a little irritating sometimes to deal with, but that's for particular reasons on some of the workflows that I'm trying to demonstrate outside of this demo. But anyway, so this is the Palomar project. Basically, it's just kind of a simple portfolio proof of concept. So there's a UI component, and then there's a couple services, one being the portfolio that manages particular users' holdings, and then a ticker that kind of gives a snapshot of what the price for each one of those companies or holdings are. So you can see our little diagram here. This is kind of what we're going to build with Istio, and kind of build this out piecewise and show some of the authentication and authorization for the services that Istio provides, how it's configured, and kind of do a little bit of digging into some of the features of Istio. So if you look at the project, I have most of the commands baked into a makefile. So the first thing I'm going to do is create our cluster. So what we're using here is K3D. I'll show, not sure why my network disconnected. So we're using K3D to create our cluster, and then after we create the cluster, we're going to install Istio on it. So Istio is more or less going to be configured in its demo profile. So there's a lot of defaults that are on there, a bunch of services that are running just out of the box to kind of demonstrate a lot of the features. It's pretty close to what I want to show here, but is a little bit less performant than some of the other profiles depending on what you're trying to do, so just be cautious of that. So we can look at the values that I'm using here, and I'll talk a little bit through what we're making sure are enabled. So the main core piece that we're doing is both authentication and authorization on all of these services. Your configuration becomes a lot simpler if you use some of the default deny rules or enforcement rules. So for mutual TLS, between each one of the services, you can force that there's a client cert that will be passed with the service. So that gives you a strong identity between services, and it allows you to force all traffic to go to come with that cert. So that gives you the authentication. So you can do it in a more permissive mode, and basically if you're not using this auto tag, you get some extra control on here. Basically what I'm showing here is kind of a strict mutual TLS authentication in between each one of the services. So that saves me from writing some additional rules. It just by default is going to force mutual TLS. And then on top of that, after we do the authentication and make sure that the transports have mutual TLS, we use policy rules in between each one of those services as well. So that'll tell you which service is allowed to talk to which service. So there's a little diagram here. If we look at kind of the setup, is we're going to use Istio's gateway for to get full telemetry through the whole system. That helps us build everything from the proxy all the way through the services, and to ensure those same authentication mechanisms from that proxy. So you can use other things like Nginx or traffic, but the Istio one kind of ties in with everything a little bit nicer. So we're going to use that gateway. I'll show that, and then mutual TLS in between each one of the services. On the receiving side, we're going to force that all services talk with the cert, and then the auto configuration in the Istio profile is going to force all the egress traffic from the pod to package up TLS as well. So there's kind of two things from the gateway that we're going to punch holes in to make accessible to the client directly, and that's going to be the UI and the ticker service, basically getting company price information and then the full what would be presented through the UI or punched. The portfolio is going to be restricted from direct access, and the ticker can't talk back to the portfolio, for instance. So those types of authorization are going to be baked in as well. Okay, so you can see that on the left here from the make file, we got Istio installed. And then if we deploy our project, this is not the most efficient way to deploy it, but basically it's going to go through each one of those projects, wrap it up, push it into K3D, and then we'll have our deployment. While it's working on that, I'm going to start up a few of the Istio dashboards. You can do this with forward, so you don't have to use the tool specifically to get at these, but it is convenient. So one of the things that we'll look at first is the tracing capability. So if we look at how Istio is going to implement all of this, each one of these services get its own sidecar proxy, and all the traffic is going to be forced through that. So when we're in the Istio mode, we actually are binding to a local host. Great line endings there. So rather than binding to 000, we're binding to our private address. So that's going to force all the traffic through the proxy. In this case, we're using Helm as the deployment. I think a lot of this cleans up in the lift to kind of get each one of the applications to understand how to fit into this. Becomes a little bit easier maybe if we use something like Customize. I haven't actually done that yet, but the hope is a lot of this boilerplate that comes with Kubernetes kind of goes away. So you can see that when we're in Istio, we bind to 127 rather than our global port. Okay, so let's go back here. So tracing is basically through the proxy, we're going to collect some telemetry there and follow like a call hierarchy, so we can see latency, but we can also see where things go. In this case, when we configured our gateway for the UI, we specified that any of the subdomains, so if we say UI out in the front of our subdomain, we are going to route to the UI service. So in this case, I'm wiring in an IP here, and I'm using this service called XIP.io. It basically just extracts out an IP from our domain and uses that to route. You can look that project up. It's pretty slick. But yeah, so if you had a real domain, this becomes a little bit more simple looking. But in this case, that's how we're routing all the traffic to individual services. So UI dot whatever is going to the UI service, and ticker dot domain is going to go to the ticker service, and that's, you can do more complex routing rules within the Istio gateway as well, which is normally supplied by most of the proxies that you have. So what that means is I can curl to our HTTPS. Well, let's look at the gateway as it stands first, and that is in the Istio system namespace. We're just using the default one that comes with it. So that means that this is the IP that we can use to route to. Again, I'm using a subdomain here in this XIP.io, which is just basically going to resolve to the IP that's in here and allow me to do the routing based on the subdomain. User one portfolio balance is just an endpoint that I have that kind of traverses all the services. In this case, I'm still self-signing these certs. So right off the bat, we can see that the access is denied. Basically, when I deployed this, I didn't provide any of the authorization rules, so everything's forcing MTLS across the board, but it is not allowing service-to-service communication. We haven't defined that rule set yet. So we can go and look at the tracing right off the bat here, and we should see basically exactly that. So if we look at one of our one of our traces is we see it, the gateway goes to the UI, just like we would expect. Gateway is going to go to the UI, but when we look at the response code, we get a 403. And that's just our default deny rules. Nothing's allowed to talk to anything. Well, we can do the same thing with the ticker again. And then we'll take a peek at these after applying the authorization rules. For the ticker, it's company name, and then ticker gives you the price at that moment. So, of course, that is also the same problem. We jump back to the tracing, we can see that we would that should give us the same deny. I'm not seeing it, but yeah, so you see it trying to, go to the ticker, and a 403 as well there. Okay, so let's fix it. Let's look at our templates and UI to portfolio. Basically, here's all the authorization policies. So I started using 1.5 because it came out last week. They changed some of the names, but it used to be policy and authorization policy. Policy referring to the authentication requiring MTLS, so you'd either pick strict or permissive. Authorization policy is for authorization. They changed that to peer authentication instead of policy, and that makes things a lot clearer, I think. So when we're looking at authorization policies, we can always pull those CRDs and build a graph to show exactly what's going on here, and that's one of the benefits is you can always get a snapshot of kind of what's allowed in your system by looking at these rules. But basically, we have our two rules here is going from the gateway to both the UI and to the ticker. So that's anything coming from the Istio system, which is how we saw our gateway being defined. And then lower, we're saying that we're allowing, these are rules from the UI to the portfolio. So you look at the service accounts that we're allowing. So the authentication provides a strong identity for these. Basically, the UI service account is now allowed to talk to an application with the label of the portfolio. And same type of thing from portfolio to ticker. So let's just apply that real quick. Okay, so it depends where you think makes sense to define these. You can lock them down to saying only a certain account, for example, like your CI service is allowed to push anything with an authorization policy, or special users can. So you can't just poke holes in your policies. Otherwise, anyone could basically poke a hole in there, even though they're still auditable. You'd be able to access any service. So just be careful about that. Figure out exactly where they should live, whether they live in the Helm charts of the individual services or somewhere else. So we go back after we've applied that rule. It takes a little bit of time sometimes to propagate, which is what we saw there. There's the company and the price. So now we're able to go from the ingress to the ticker. And then let's take a look at the balance one. It's a little bit more involved and interesting. So there we see kind of the result of this endpoint. So let's bounce back real quick to our UI, or to the tracing UI, sorry, and looking at that entire chain. So this is a nice layout, and it kind of shows you exactly what we'd expect from our graph. The gateway talking to the UI, and the UI talking to the portfolio, and then each one of the portfolios then turning around and talking to the ticker. So you can start kind of laying these out, seeing the latency that's involved in them. In this case, I think we can see some of the tracing is less than ideal, right? These are being done sequentially. They're not in parallel. So if you had a whole bunch of companies, maybe that ends up being a slowdown, and you can kind of see that sort of traffic. You can instrument basically any of your code. This is a I'm doing a pretty naive solution to getting this instrumentation. You can instrument like databases and stuff and then get these into the fold as well. So this is kind of the open tracing project. This is the Jaeger tool for visualizing that. It's not really an Istio thing, but it does help you get, Envoy will help facilitate some of that. The main problem from a project perspective, which I think is kind of the goal of this project, is to look at it from each project's development standpoint. So in this case, it's not great because basically everyone has to forward their headers from their application code, and there is no way for Envoy specifically as a sidecar to correlate incoming requests to outgoing requests and making sure that those are in the chain. So what that means is you need to either use open tracing friendly library as a wrapper or monkey patch or something in your code, or to make sure that you're forwarding the headers. It's pretty easy to forward the headers, honestly. You get basically anything with this XB3 you want to forward, and then Envoy basically will take care of the rest of it. You don't have to do too much logic there, but one bad behaving thing in the chain will pretty much break your entire tracing. So it's a little difficult to employ, I think, but the capability's there. Other things that are there, you get most of your telemetry that you'd expect, right? You get graphs into a Grafana or into Prometheus, and then you can visualize them in Grafana. I guess in this case, maybe workload. Let's just do a little bit of load testing on this. That's remarkably low, so I think that was maybe, we'll rerun that in a second, but hopefully we can see that these graphs are kind of correlated with what we have there. We could use this to kind of find those bad responses before and find the broken services. Yeah, it seems to be particularly low compared to what I normally get when I've dry ran this before. So I did a standalone version of this, and this was reaching 134 requests per second. Normally this gets a little bit closer to that, so it's not a perfect environment. And the baseline test that I'm running as well is, I ran it without recording, so I'm sure that the resources I'm using for recording are chewing into this. Basically, I'm seeing 5% slowdown or so when I'm running with tracing and all the proxying and HTTPS. I haven't turned off tracing specifically. I think it would pretty much be negligible in terms of like using the zero trust model. You'll get some slowdown, but I don't think it's going to be a huge impact for most cases. Run these benchmarks yourself. I guess there's a task in the make file to deploy standalone, and you can use this hey utility to basically do benchmarking. So I encourage you to do that on your own machine to get closer results. So the other thing I wanted to show was that TCP is also available in the same thing, along with like gRPC and some of these native transports. But TCP is, you can do the same type of thing with authorizations, so that if you had databases or something, you can enforce the same type of authorization between your services as you could anywhere else. So in this case, I'm just going to do a quick thing to the ticker. Basically, this just allows you to stream results to it. It's a very simple service, and it's only going from the ingress in, but it kind of is meant to demonstrate that same type of thing. So in this case, we're hitting the gateway and then streaming ticker information. So you get kind of those same assurances, whether it's TCP or it's HTTP. HTTP has maybe more tooling, but all those types of services are supported. So as I said, I think the main thing we kind of want to take a focus, or to be focused on, is what does Istio provide? What does it force each application developer to do? In this case, it's providing us HTTPS, a strong authentication and authorization mode. forcing things through the proxy is an intelligent way to make sure that we can push common configurations for things like telemetry to each one of the services without them having to think about it. So you get auditing, logging, those type of things consistent across all the services. So when we look at what you're actually writing, I know I was showing some of the tracing. If you ignore tracing, is you're really just writing a simple HTTP service, and you're providing a health check here, but otherwise you're writing as simple of, in this case, flask as possible. Outside of that, you have to write some way to deploy into the cluster. You don't get away from deployment in an automated way anyway, so being a little opinionated on how applications are deployed is probably a positive thing, but there's certainly a learning curve to figuring that out. So looking at tooling and things, customize or whatever other tools that can lower that burden for each one of these services that you see here is kind of going to be some of the next focus, and trying to figure out the best way to keep the platform out of the ways of the application developers, or for the services specifically. So that's pretty much what I have. I think Istio kind of has a learning curve, but once you kind of understand and are able to adapt it into the applications, the utility is significant enough to make it worth the while. So that's what I have for now. Thanks.